Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about water jet laser or micro laser jet or whatever have you. It has many names. So what is the problem with normal system that we utilize on day-to-day basis? Well, laser system, while they do work, they are absolutely amazing, they do have some problem. Primary of being a small work distance. What does that mean? That simply means if you have cut through thick material, the amount of material that you will waste, let's say basically how wide your cut will become, it becomes exponentially higher. So if you want to cut through thin materials, 1 or 2 millimeter, 5 millimeter, 1 centimeter, that's more than good enough for laser. But the moment you start to go into inches, as in like 2 inches or around let's say 50 millimeter, it can still cut through, but the amount of width, basically the spacing between cuts would become exponentially higher. So fundamentally it does have that issue. So we require extensively complex focusing system to focus the laser, because you may think, okay, laser is like 2 kilowatts, that's a lot of power. Not really. 2 kilowatt of power, like if you spread out over a large area, that's like a halogen light bulb. So you have to focus it on a small concentrated point. That's how it works. So you have to understand, focusing system for laser that can cut through metal, it's very expensive. Then we come to another aspect, heat damage. You may think, okay, laser is just focusing on a small point. Yes, it is doing that, but there are many things that are conductive and it is still dumping a lot of heat, is still melting it through. So there is a lot of heat damage on the surrounding area. So yeah, what you're cutting through, you have no problem in that specific spot, but you do not want it to warp in the other ways. And that's why like many laser cutting machine will have a minimum thickness specified. You can cut through thin material, but it will be warped. So fundamentally these are the two primary concerns. Then we come to EMD. EMD is really good, really precise, but does require what we call pilot hole, so to say. So if you have to cut through something inside something, you have to have a lot of wastage space. Otherwise you basically the thread that you have to do the cutting with cannot directly go through a material. You have to send a basically milling operation that allows you to drill through, then you will thread the cable and then you can cut out whatever you want to do. So fundamentally you have to waste material. Or if the material is extensively hard, let's say like diamond or some specific carbide, that operation alone would be more expensive than anything else. And then EMD does not work on anything that is non-metallic. The only way you can make it work on basically dielectric materials is basically you have to keep coating it. So that's the severe limitation of EMD. Then we come to water jet. While they do work, they are amazing, reliable, awesome and all that jazz, they do classify as blunt instrument. If you're gonna go to someone and it's like, okay, can you give me this piece in within, let's say 1 millimeter accuracy, they're like, got this. Water cutter, got this. The moment you start to add zeros to that, then like, yeah, water cutter can't go very deep. Like again, there are some very ingenious machines that can go really precise, but not precise enough where you will utilize this with something very high end. So it is considered as a blunt tool. It's like it's very good for cutting granite for your basically countertop and things of that nature. It's amazing for that. But if you want to do precise instruments, it's not something that you want to utilize. Then we come to plasma cutter. When you have to go through thick metal, this is one of the cheapest and most effective tool. Consequence of that, it is inherently messy. It's basically creating a puddle of mess. And what does that translate to? Think of it this way. Let's say you are running a factory that is like, okay, we're gonna cut through let's say sheet metal and we're gonna make bulldozer out of it. Awesome, super awesome, but sheet metals are thick. If you cut it through plasma, you have to spend extra step to collect the metal, grind the edges, clean the edges, balance the edges, then you do the welding stage. So fundamentally it adds extra step because the cut quality is very low and it does have very high heat damage. So fundamentally speaking, if you are utilizing something thin or where you do not have enough cooling, you can literally warp a metal, and in this scenario it can warp even a thick metal. So like 5 millimeter thick metal can be warped in plasma if it's not precisely controlled, and the cuts are fundamentally ugly. So that's the limitation. So that's what the idea behind this technology is. Basically you are taking the laser and coupling it with water jet. Now, if water jet is done correctly, you can have a flow of water that is like a cylindrical, almost a perfect cylindrical for throughout some distance. Now, again, in movies, you see laser that's going wee for very long, that till infinity. In real life, that never happens. In real life, there will be a focusing system that's going to focus, and then where you have sufficient intensity, you can cut through the material. So there would be a working range, what we classify it, and that's why the focusing system is not even a static system. It's like the laser lens, it adjusts. Sometimes it even auto focuses to make sure it has precise cut. So utilizing water as a carrier of it, you can have a scenario where you have a movie like cut quality where it's like, okay, I have a light beam and that can cut through whatever I want to cut it through. So it allows laser to work over distance. So you do not have to just like almost touch the goddamn material that you're cutting through. That does have consequences, like especially if you are cutting with some materials, specifically some carbides and some other things like that, they have a tendency to like bulge up, like stuff is coming out of here. So fundamentally you may not want that. And then you have water. Now water has this advantage of being a cooling substrate. Basically you are, whatever you are cutting, let's say a silicon die or carbide system, it will trap heat very efficiently. But if you have water directly going there, it will cool it down fundamentally. So the heat damage would be much less. And that's the one thing you have to understand when you are dealing with something expensive like diamonds. Having a basically cone kind of cut fundamentally means you have to grind it away one way or the other, and you cannot throw either piece away. When you are dealing with something cheap, you can just throw the wasted material. When you're talking about diamond, every single gram matters. So you have to understand that. That's why water helps. The cooling is also very essential. And what do you get? What you come once you combine laser with water jet, you get what we call deep taper free cut. Very high quality deep taper, basically almost the same quality or higher quality than what we call in EDM, but on any material, and does not require basically plunge cut, where you can plunge another EMD tool to make a threading hole, then you do the threading. You don't need that. So that's why people wanted to invest in this technology. So how does this work? Well, it utilizes laser power. The cutting action is still being done by laser. So you will have laser beam that would be around 20 watts to 400 watts. I'm talking about one specific machine where I could find this schematics. And this will be around green laser. Specifically, green laser has to be precisely chosen. You cannot just use any laser bandwidth if you want. Basically, you cannot use CO2 laser. It has to be green laser. Then you can have a focusing element, but it's going to focus into a chamber where you have the nozzle. Basically the water jet part, it will have a nozzle. That nozzle is the focus area. Basically your lens will focus on the water jet area, and the water would be very pure and very high pressure. And in terms of pressure, you are talking about 800 up to 800 bars. That is ludicrously high psi, as in around 20,000 psi or more. So you need a lot of high pressure clean water there, and then you need laser that is directly focusing on the nozzle point. Now here's the magic element. Because of the transition layer that's happening in the water column, basically if you look at the water column, you have air and you have water. What does that create? That creates a place where you have internal reflection change. So that's why the green laser is very specific. If you use any other laser, there is a chance it may not reflect inside, or it may just scatter outside. So green is precise, because if water air interface leads to what we call total internal reflection, basically it becomes like a fiber optic. That's all it is doing. It's like becoming a fundamental fiber optic, but you just don't want to put your hand through that because it will simply cut through it. So that's the main point. Green wavelength is specifically chosen for that, and it gives them the working distance, which for something as weak as 400 watt laser, and you're gonna say to anyone, I can cut through reliably, without requiring autofocus mechanism, 5 millimeter to 50 millimeter, they'll laugh at you. It's like, that's not possible fundamentally speaking, but this can do that. So what does that mean? That simply means if you have a material that has its height is changing, basically you have step kind of structure, it can handle that. That's not an issue. You can do any weird angles also if you need to. So that's the whole point of working with this technology. So you have a laser that focuses on the nozzle. Water creates a basically nozzle scenario where you have a complete cylinder. That cylinder acts like a fiber optic system where the laser is reflecting inside, not outside. The moment it touches the material, it dumps the energy on the material, and materials get cut through. And because so much water is flowing through, it is also acting as a very good cooling system. So if you are dealing with something that traps a lot of heat, you do not have to worry about that. So these are the primary working principle of that. So you have a laser system and a water jet system. Now, what are the uses of something this convoluted? Because again, it's a complete laser system and a complete water jet system. Now, be mindful, water jet system does require what we call abrasive. It does not require that. So it allows what we call high aspect precision operation. Basically, if you take a width of a cut and you take the depth of that cut, if the depth is much higher, let's say by 10 to 1 or 20 to 1, so basically your width is, let's say, 1 millimeter, but depth is, let's say, 5 centimeter, that's a very higher aspect ratio cut. Now you can do high aspect cuts from many equipments, but precision always suffers when you start to do very complicated stuff. So this equipment will be utilized when you need very high precision while needing high aspect also. So in those sort of scenarios, you will utilize this, and this puppy is really good for very hard material. For example, metal. Now you may say metal EDM can also do that. Yes, that's absolutely true. However, ceramic EDM is like no, flat out no. So the moment you start to touch ceramic, EDM is like I can't deal with this. Composite, basically carbon fiber or some other stuff that you have to deal with, this will not work. This will easily chew through it without any issue. Silicon carbide, it is generally utilized for very high-end basically watchmakers, where watch gears are made out of silicon carbide, and like the watch I'm not talking about, it makes Rolex look like a cheap stuff. So those system use diamond, like there are few machines in India that is being utilized, and I was like, what the heck they are using it for? Diamond. India does have a Surat, which is like almost considered as a diamond capital of India. So diamond machining is also done for again, you can do that on artificial diamonds or natural diamond. It can simply cut through that. So jewelry industry, tool making industry is very interesting use of that, because think of this, whenever you see any video of any machine that is just cutting through, like just that's the carbide tip and this is going through material, how the heck you cut through that goddamn material itself is so strong that if you utilize on any normal metal, it's gonna cut through the metal. It has to be harder than the metal to cut it. How do you cut it? Now normal laser can cut it, but it will create such a weird shape, and the shape of basically tool tips have to be precise, and I mean idiotically precise. If they are not precise, they will simply not work reliably, efficiently, long enough. Basically, you can have a tool tip that has been not ground properly, everything is same in the same machine, and you have another tool tip that is perfectly grounded. You will have a scenario where it's like, oh, perfect tip is like just cutting through without any issue. But if you have not properly grounded it, that destroys your material. So fundamentally tool making also uses that. And then we come to aerospace. For example, one of the hottest component in a normal commercial air jet system is generally what we call turbine. Compressor blades are dealing with normal atmosphere, it's a bit hot but not too much hot. But when you're talking about like when you burn it through after the combustor, it's hot, as in upwards of 2000 degrees Celsius kind of hot, ludicrously hot. Even with air curtain is still like around 800 degrees Celsius hot. So that hot exhaust is directly hitting the turbine blade. Now turbine blade will simply melt if it does not have what we call cooling holes. So generally nowadays we utilize titanium, ceramics. Those things generally can only be dealt with this kind of equipment. There are some other equipments that people are trying. People are also trying 3D printing it, so they will have like a internal cooling channels built into it. But you get the point, like it's very difficult in those sort of scenario. People want to utilize this sort of tool. So jewelry, tool making, aerospace, people have to use something this powerful. Now what we can expect in the future, one thing you have to understand, this tool is not suited for everything. Every time some new tool comes into the market, many times people have that this will replace everything else. That's never gonna happen. That's just simply nope, never gonna happen. You have to understand that in engineering it's a basically art of compromise. What do you compromise? For example, this tool, while on paper it is amazing, it does have very basically limitation in work volume. Basically, if you go to a large shop and be like, okay, how thick of a material and how large of a sheet material you can handle, this machine is like, yeah, we measure our work volume in basically like a small 3D printer. I'm like talking Ender 3. It's like, yeah, 300 millimeter by 300 millimeter by 300 millimeter. That's not big enough. When you're talking about industry, they need to cut through like, foot by foot or meter by meter, like 1 meter across by like 5 meter across. The moment you have to deal with those kind of material, this machine is not good enough for that. That's why I specified, if you want to deal with high precision small equipments, that's awesome, but not for large. Even though it does have some benefits, but it does also have the complexity of basically needing a complete laser system and a complete water jet system. So it does not have large work volumes, and then come the consequence of large capital cost, because it has two independent systems, both are expensive, and then water uses. Now many places of the world water is very cheap, so you don't even care about that, but some places water is taxed, and the industrial use water tax is much higher. So if you're like, okay, this machine drinks water like there is no tomorrow, of course if you're working in diamond industry you can afford that. But if you're not working in that, you may be like, yeah, we can't afford that. So many times people are like, okay, even if other things are we are utilizing, people want to use that. And many industry tools are switching to going from water cooling to air cooling simply because of that. It's like water is an expensive equipment. And then you have to understand, look at this tool as a one more tool in your tool shed. Do not look at it as like, if I buy this machine it will solve our problem. No, it's like you may have a scenario, it's like, hey, investing in a laser solves more problems than investing in this system. But if you are dealing with something very precise, let's say watchmaker, then buying something like this is precise. Basically if you are only focusing on basically jet engine turbine blades, this is perfect tool for you. So that's the whole point of it. It's just an extra tool which does utilize a combination of total internal reflection, water jet, and laser. So this was my presentation on water laser jet cutter. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.